This is solving a tax rate or interest rate problem using a system of linear equations. And I was getting ready to write this. All of the problems that you'll see in this topic are based on the idea that if you are trying to take the percent of something, so it's probably going to be money for this topic, then you just write your percentage as a decimal and you multiply by that dollar amount. And so we're going to see that, or at least the way I like to do it, is to set up a table and we'll be like multiplying across. We'll have our dollar amount times our percentage to get whatever that percent of value is. Anyway, so this particular one is Kareem bought a desktop computer and a laptop computer. Before finance charges, the laptop cost $250 more than the desktop. He paid for the computers using two different financing plans. For the desktop, the interest rate was 8.5% per year, and for the laptop, it was 5% per year. The total financing charges for 1 year were $296. How much did each computer cost before finance charges? By the way, it has this thing about using the Alex graphing calculator. I think that's more trouble than it's worth, but we can talk about when that would come into play. So before we can do that, we have to come up with some sort of equation, though. And so I like to do a table. So we've got the two different kind of quantities or accounts or whatever are the laptop and the desktop. And then they do have things about total. So I'm going to have a third row for the total. And then my three columns, so it's always a 3x3 table with these. My three columns are going to be like the base price, like before finance charges. So I'll just say the price, I guess. And then the financing, the interest percent is going to go in the middle, and I'm going to convert that to a decimal. And then if I multiply across, that's going to give me the finance charge. So however you want to write that, finance charge, I guess. I'll just write it out. Okay, so let's see what we've got here. They said the laptop cost $250 more than the desktop. Okay, I'm not sure where to put that $250, so I'm just going to hold off on that. All right, desktop, the interest rate was 8.5%. All right, so 0.085. And then laptop 5%, so 0.05. Total finance charges for 1 year were $296, so that should go here. How much did each computer cost before finance charges? So I could do X for the laptop cost, or I put price, and Y for the desktop price. And we don't know the total. We know something about some kind of way X and Y are related, but I don't know that we're going to want to fool with trying to fill in the rest of these boxes in the total row. So I'm going to go ahead and multiply across to fill in this last column. And you should always be able to get one equation at least from this last column. So we'll have 0.05x will be the amount of the finance charge for the laptop, and then 0.085y for the desktop. And so if we add these together and set it equal to the total, that gives us one equation. So 0.05x plus 0.085y is equal to 296. So then our other equation is going to involve this 250. So the laptop, that's our x, costs $250 more than the desktop. So x is 250 more than y. Or to me, it makes sense to write that x equals y plus 250, or 250 plus y. It doesn't matter if you're adding what the order is. Okay, there we go. There's our two equations. And so it happens to be already set to use substitution because we've got x isolated, so we can substitute in to the x in the other equation. And so we can get the equation, we'll go over here, 0.05 times the quantity y plus 250 plus 0.085y equals 296. And so now we can solve this to figure out our y, and we'll go back then and plug in to get our x. So distributing, we get 0.05y plus, I think I'm going to use a calculator for this. It's something like 125, I don't know, 1250 maybe? 0.05, shoot, 0.05 times 250, 12.5, okay, I was getting there. And then plus 0.085y is equal to 296. And so combining our like terms, the y terms, 0.05 plus 0.085. For some reason I'm having trouble using a calculator today. Okay. So 0.135y plus 12.5 equals 296. So if we we can solve by subtracting 12.5. So 296 minus 12.5 is 283.5. Let's go over here. So we have 0.135y equals 283.5. And so finally we can divide by this 0.135. Okay. So 2100. Y equals 2100. And so we have to look and see what the heck y was. That was the price of the desktop, or cost of the desktop. So the desktop cost $2,100, which doesn't seem unreasonable, I guess, depending on what kind of desktop you're getting. So then we still, though, need to figure out how much the laptop costs. So the laptop costs $250 more, right? So 2,100 plus 250 is equal to $2,350 for the laptop. Okay. And so to use the graphing calculator, after you get these two equations, what you do is solve both of them for y and put them into the y equals, and then you look at what the point of intersection is. It gets a little tricky though, because you're dealing with really large numbers and you have to zoom out a lot to be able to see this point, 2000 something, 2000 and something. So I think it's, again, more trouble than it's worth. So we're going to look at one more of these and at least set it up. All right, so last year Tammy had $20,000 to invest. She invested some of it in an account that paid 6% simple interest per year, and she invested the rest in an account that paid 8% simple interest per year. After 1 year, she received a total of $1,500 in interest. How much did she invest in each account? So yet again, we have kind of two different quantities, in this case, accounts that we've invested in, and two different percentages, two different interest rates. And then we have something to do with a total that they gave us. So I'm going to do another table, another 3x3 table. And so my two different accounts are my rows. So they didn't really name them. So I'll just do like account 1 and account 2. And then the total. And just make sure that you always put the total or whatever's going to be the end result kind of last. Okay, so then the amount we're investing, that's usually called the principal. That would go first. You could just, put amount or something, but this is a larger dollar amount. And then the percentage goes in the middle, and we're going to, again, make that a decimal. And then if we multiply across, that's what gives us the dollar amount of interest. So this is dollars, and this is dollars. So last year, Tammy had $20,000 to invest. So that's the total amount of principal. So that's going to go here. She invested some of it in an account that paid 6% simple interest per year. So 6%, we'll make that the first one, 0.06, and the rest in 8%, so 0.08. After 1 year, she received a total of $1,500 in interest. That's pretty good. So that's down here, right? Total. And as long as we have kind of both the first and the third boxes or whatever in the total row filled in, a lot of times you're not going to need to worry about whatever the percentage is. This would be something kind of, I don't know, around 0.7, something in between these two, but we don't care. Okay, so how much did she invest in each account? Well, let that be our X and our Y. So we actually can get one equation already from this very first column, but I'll go ahead and fill in the whole table. So X times 0.06 would be, why did I put Y? An expression for the interest, and then Y times 0.08, so 0.08Y. So interest for the second account. And so if we add each account's interest together, we should get the total interest. And same thing for the first row. If we add the amount in each account equal to each other, then we'll get the total amount that she invested. So these are going to be our two equations. So I'm going to write the more complicated one first so I can line things up better. So 0.06 X, why do I keep wanting to write Y? Okay, X plus 0.08 Y equals 1,500. And then X plus Y equals 20,000. And so you could do elimination with this, it wouldn't be too big of a deal to do that. Just multiply through by, like, say, negative 0.06. But you can also do substitution. Solve, maybe say solve for X, subtract Y from both sides. So I think either method would be 6 one way, half a dozen the other, right? So maybe since we just did that previous one with substitution, I'll do elimination on this one. So I'm going to multiply through on this second equation by negative 0.06. I may decide that I wish I had done substitution, but that's okay. We'll see what happens. So if I do that, I'll have negative 0.06x, and then minus 0.06y equals a negative, okay, let's see what that is, 20,000 times 0.06, so negative 1,200. And then let's line up that first equation we wrote, so 0.06x plus 0.08y equals 1,500, and add these two together. Get a little more room here. So the x's eliminate, which is the intention, and so we have 0.02y equals 300, dividing both sides by 0.02. I think it's like 15, I don't know. I have trouble doing a bunch of decimal places in my head. 0.02. Yeah, 15,000. I should have more confidence in myself. Okay, so y equals 15,000. So that was the amount invested in account, what we called account 2, but at 8% interest. So maybe I'll write that. I think that's kind of what the answer box will look like. So then to figure out the amount invested at 6% interest, well, we know they add up to 20,000. So you might be able to just go, oh, it's going to be 5,000. But if not, depends on the numbers. You can plug into that other equation since it's simpler. That's why I'm picking the second equation. So x plus 20,000. No, I'm having all kinds of issues with this video. Okay, x plus 15,000. That's our y is equal to 20,000. And so we can now easily see that, okay, subtract 15,000 from both sides, and we get $5,000. So $5,000 was invested at the 6% interest. And there we have it.